Here's a perfect example of a data sufficiency question that most people have so much trouble with. What I found is as far as all the data sufficiency problems are concerned, the ones that are either algebra related or number property related tend to be the most challenging for people, mainly because they don't know what it is that they're supposed to be tested on, or what they're being tested on rather. Anyway, in this case, what you can see is the question is x odd? And statement 1 says x cubed is odd, and statement 2 says x squared equals x. Most people, when they look at this, think it's much easier than it really is, and they attack it too quickly, and I would say maybe 99% of the people are going to get this one wrong. Anyway, the trick of this type of question, you could tell based on the question itself. They want to know, is x odd? And so if, for example, you start inserting numbers for x, it's very difficult to answer, is x odd or not? So the recommendation I have is pay closer attention to the facts in the problem. In this case, you could see x cubed is odd. So the only thing we know for sure is that x cubed is odd. So what I would do for statement 1 is I would say x cubed could equal, with simple inserting, 1, 3, 5, or 7. And that way, I can solve for x in each case. X equals 1, or x equals the cube root of 3, or x equals the cube root of 5, or x equals the cube root of 7. In this case, I can see when they ask, is x odd? In this case, x is a 1, which would give me a yes. In this case, I see x is the cube root of 3, which would give me a no. So that would tell me sometimes yes, sometimes no. Therefore, statement 1 is insufficient to answer the question. Now, when I look at statement 2, I would say the biggest mistake people make is they think when you see x squared equals x, you can simply divide both sides by x, but that's not true. What you need to do whenever you're working with a quadratic, an x squared, you have to set everything equal to 0, and then you could solve for x. For example, x squared minus x equals 0. So you'd have x times the quantity, x minus 1, equals 0. Therefore, x would equal 0, or x would equal 1, which means for the question, is x odd? For the 0, no. For 1, yes. So once again, we have sometimes yes, sometimes no. So statement 2 is insufficient. Now, when I put both statements together, statement 1 and statement 2, I can see the only thing that works in both statements is when x equals 1. So this would tell you x equals 1 and only 1. So therefore, is x odd? Definitely. So the answer would be C.